The scanner is a powerful addition to the absolute Master3DGage for many reverse engineering workflows. Although it's possible to scan an object and extract features from the mesh, in most cases it's faster and more accurate to reverse engineer prismatic features using a probe. Likewise, it's possible to fit a complex surface to probe data, but it's more convenient, and often faster and more accurate, to measure surface contour with a scanner. The ease with which the absolute Master3DGage switches between probing and scanning makes it simple to use the most appropriate method, even for different steps within the same workflow. I'll demonstrate this by combining both techniques to reverse engineer our demo part. To save time, I've already aligned to the part and measured the prismatic features using the probe. I've also exported the features to CAD and created solid bodies from the sphere and cone for use in later operations. We're now ready to measure the complex surface on the top of the part. I'll start by measuring the same features I used for the initial alignment. Since I'm measuring the table in lieu of the bottom of the part, I've used clay instead of tape to secure the part to the table. After running the alignment, I'll measure lines along the other two sides of the part, and I'll measure a spline along the front. We could scan this surface, but it's faster to extrude it, and it simplifies the workflow. Once the edges are measured, I'll export them to CAD and trim them together to create an outline of the part. We'll use this outline to extrude a solid. From the Solids menu, I'll choose Extrude. I'll then select the curves and extrude the solid to a height that extends beyond the top of the part. In order to trim the solid, we'll scan and then surface the top of the part. I'll hide our current work so we can focus on the surfacing. I'll then replace the probe with the scanner. I simply turn the lever to release the probe, then position the scanner and lock it in place. I'll start by scanning the top of the part at full resolution. We don't need much data for a surface patch, so I'll filter the cloud to a 50,000th spacing. I'll then delete the points on the front edge of the part, since it's more accurate to form this surface using a fillet. Finally, I'll use the patch tool to create a surface through the cloud. I'll use the dialog settings to control both the accuracy and complexity of the surface, and I'll extend the surface slightly for use in trimming the solid. Once the surfacing is complete, we have everything we need to finish the model. With the rest of the model now visible, I'll trim the solid using the surface patch we just created. This gives us the basic shape of the part. We'll finish the model by filleting the edges and extruding the prismatic features. I'll choose the Solids option, Constant Radius Fillet, and then select the corners of the part. In the Fillet dialog, I'll enter a radius of 1/8 of an inch. I'll follow the same procedure to put a 100,000th radius fillet on the top front edge. On the bottom of the part, I'll use Solid Extrude to create the hole pattern, the slot, and the rounded triangle to a depth of 3/8 of an inch. I'll then create a pocket around the boss to a depth of 1/4 inch. Finally, I'll use the Solid Boolean command to form the spherical and conical features from the solid bodies that I created earlier. That completes the process. We now have a single body, solid model of the part. Solid modeling allows us to take advantage of Verisurf's model prep tools, which make it easy to incorporate design intent into the reverse engineering process. For example, if we know that the holes in the pattern should all have the same 3/8 inch diameter, the push-pull tool allows us to change them all at once. In addition, the Move tool would allow us to reposition the pattern. The Master3DGage scanner is ideal for reverse engineering freeform objects such as artwork or consumer products, where aesthetic considerations are most important. I'll demonstrate by creating a solid from a scan of this foam toy. I'll start by scanning the back of the dolphin. As I did before, I've set the bounding volume to ignore the tabletop. Next, I'll make additional scans of the bottom from 2 orientations. I could have mounted the toy so that all surfaces were visible from a single position, but that's not always an option. When I've finished scanning, I'll edit the point clouds to remove stray or isolated groups of points. I'll also filter the clouds to uniform spacing to simplify registration. The use of averaging here helps to reduce scanner noise. The point clouds were measured in different orientations, so they need to be aligned. I can get them close using register to point clouds, or simply by translating and rotating them using X-form. I'll then register all three clouds to one another using a best fit. Once the clouds are aligned, I'll merge them into a single cloud and then use filtering to average the overlap. Next, I'll use the Mesh tool to create a 3D mesh from the cloud. Using Mesh Edit, I can apply local or global smoothing, fill holes, or make other modifications as necessary. I'll then filter the mesh to enhance regions of high curvature. The mesh is complete, so I'll run Auto Surface and select simple, freeform surfaces with minimum detail. When I choose Create, VeriSurf automatically generates a model using multiple surface patches, each with a different color. Finally, I'll choose Solid Create from Surfaces to create a solid model of the dolphin. As a final check on the results, I'll use VeriSurf Analysis to compare the original point cloud to the finished model. We've now seen how to use VeriSurf with the Master3DGage scanner to reverse engineer parts using both probe and scan data. We've also seen how to use VeriSurf Analysis to verify the accuracy of the model. You've just seen how the VeriSurf Scan, Analyze, Report workflow helps automate the inspection of surface profile, and how VeriSurf's real-time surface inspection tools provide immediate feedback on tolerance condition. You've also seen how to reverse engineer both prismatic and freeform parts using the Master3DGage scanner, and you've seen how to verify the results.